Here we're going to look at how to construct a confidence interval for mu with sigma known. And whether or not knowing sigma is realistic is beyond what we need to worry about at the moment. Again, we're just going to assume that we know sigma to develop the theory. We have a margin of error E, which is Z star times sigma sub x bar. Now Z star is just a Z-score, so we'll talk about how we get that in a second. And then sigma sub x bar, that's your standard deviation of your SDSM. Remember, that's just your sigma over the square root of n. So your confidence interval, you take your sample mean and add or subtract a Z-score, Z star, times the standard deviation of your sample means. And that may look confusing right now, but you believe me, when we get an example of this, you're going to see how those numbers plug right in there fairly easily. Z star is sometimes referred to as the critical value, and it's the Z-score that corresponds to our confidence level, or our level of confidence, C. We are C% confident that our interval contains the population mean, or we expect C% of the confidence intervals that we construct to contain mu. And from previous videos, we've seen that that C value are numbers like 90, 95, and 99%. Okay, these are very common confidence levels. Now you can see the critical value Z star there, but I'm going to explain where those come from right now. Okay, so when we construct a confidence interval, what you're basically looking at is the middle C% of your SDSM. Remember, your sampling distribution of sample means is just a normal curve. Okay, so if you're looking at a normal curve, a 90% confidence level says that we think our mean is in the middle, right? That's our best guess. And then we're going to go the same amount below and above that sample mean. So if you want to be 90% confident, you're going to have 90% in that middle. If you want to be 95% confident, then that in the middle percentage is going to be 95%. Okay, if you want to be 99% confident, then that middle is 99%. Okay, so how you actually find those, I'm going to show you a couple different ways. Okay, one way is just using your Z tables. So if you want the middle 90%, so on our Z-axis, remember 0 is in the middle because your 0 standard deviations from the mean. The middle 90% means you have 5% on each end. So basically you have 10% left over because you have 90% in the middle, so there's 10% left over to split between the two ends. Because of the symmetry, they're going to be the same. So you have to find the Z-score that has 0.05 to its left. And one way is to use your Z tables, which I've shown you before. Okay, another way is to use your calculator. And this will be an acceptable way because at this point I'm going to expect that we can use our Z tables. You go to second vars, the distribution, and we're given a percentage on our normal curve, so that's our inverse norm. Okay, and what we want to find is when you put the value in inverse norm, it's the area to the left of the Z-score. So the area we know is 0.05. So we do that and we get negative 1.6448. So if we round that, I round it to 1.645. Now it gave us a negative just because that's the y, but because of the symmetry, these are the same. So your Z star value, you can just look at that as the positive Z score. Okay, 1.645. Okay, another way to get that value is on this different table that we're actually going to use later on in the course. Okay, the T distribution, and I'll post this online as a link, or a version of it at least. And what we might notice is confidence level 90%. Okay, ignoring everything else, just look at 90% confidence level. go all the way down, and notice at the bottom here, it has a Z star value. And that gives you 1.645 as your Z star value. Now this will probably be the easiest way for you to find those values is to use this table. Okay, but remember essentially what it is what Z-scores have the middle 90% between them. Okay, for 95% it's very similar. You get plus or minus 1.96. So 95% in the middle. You have 5% to split between the two ends. So if you do 0.05 divided by 2, you get 0.025. Inverse norm, 0.025, gives you negative 1.96. Okay, and there, a 95% confidence interval in this table. Go all the way down to the bottom. You get 1.960. Okay, for the Z star. Okay, then the last one was a 99% interval. So a 99%, if you trace that all the way down, that gives you 2.576. And you'll notice that's a little bit different than 2.575. And your calculator also rounds to negative 2.576. The reason I put 2.575 is because I use the table on the Z-scores, and this 0.055 is halfway between 2.57 and 2.58. So I just average them together. Now you can use either of those values and you'll be fine. Okay, so if you want to use 2.576, that would be fine. Okay, so remember to use the Z-scores for a Z star, by the central limit theorem, we must have an approximately normal distribution or n greater than or equal to 30, a large enough sample size. Okay, so a very fast example of this. Okay, and again, I think you're going to look at these confidence intervals and say, wow, those are pretty easy. 32 small businesses ran promotions for an average of 12 days. Construct a 95% confidence interval for the mean number of days a small business runs a promotion with sigma equals 2.1. So all the way to the top of the page was our formula. X bar plus or minus Z star times sigma sub X bar. X bar is your sample mean. So we don't know the population mean. We're trying to estimate what it is. The mean number of days all small businesses run a promotion. Okay, so our best guess is our sample mean, X bar. And then we're going to add and subtract Z star times sigma over square root of n. So go through and plug your numbers in. The sample mean, they told you was 12 days. Z star, your 95% confidence level, that was 1.96 up here. And then sigma, they tell you is 2.1, and then n is 32. Okay, so go through and do those calculations. I always want to see what that margin of error is. So I want to see that 0.73 written down, and then you add and subtract that from the sample mean, and you get an interval of 11.27 to 12.73. So we're 95% confident that this interval contains the true value for the mean number of days that all businesses run a promotion.